Ladies and gentlemen, let us have a look at applications of differentiation in the calculation of velocity and acceleration. Now, I want us to look at velocity and acceleration, that is their definitions. Velocity is the rate at which displacement changes with time. It is the rate at which displacement changes with time. I have said that velocity is the rate at which displacement changes with time. Now, displacement is denoted by capital S. Displacement is denoted by, that is capital S. While time is denoted by small t. Time is denoted by small t. Now, from the definition of velocity, we can say that for you to obtain, that is velocity, you have to differentiate displacement with respect to time. That for you to obtain, that is velocity, you have to differentiate displacement with respect to time. Secondly, acceleration is the rate at which velocity changes with time. That acceleration is the rate at which velocity changes with time. Now, from this definition, we can say acceleration, which is denoted by small a, is obtained by differentiating this, that is velocity, with respect to time. That for you to obtain acceleration, you have to differentiate velocity with respect to time. Now, let us have a look at this question that deals with velocity and acceleration. The question is, a particle moves in a straight line such that after t seconds, its displacement s meters from a fixed point is given by s equals to 4t minus 2t squared minus 5t cubed. That is the equation of displacement. The equation is, find the velocity at t equals to 3. That is, find the velocity at t equals to 3. Now, we have said earlier that for you to obtain velocity, you have to differentiate displacement with respect to time. Now, since we have our displacement as that is 4t minus 2t squared, that is minus 5t cubed, we have to differentiate this displacement with respect to time. Therefore, we shall have, that is our phi, as we have to differentiate this equation of displacement with respect to time. This is a polynomial. So we have to differentiate each term in turn. So we have to differentiate the first term, then followed by the second term, then followed by the last term. So for us to differentiate each term in turn, we have to multiply the power by, that is the power of the first term with the first term, then we reduce the power by 1. Then the second term the same way, the third term the second, that is the same way. Now, this will be, the power of t here is 1. So we shall have 1. We multiply with 4t raised to 1, but we less the power by 1. Then minus, the power of t here is 2, so we multiply with the term 2t raised to 2, but we less the power by 1. Then minus, this minus, the power of t here is 3, so we multiply with the term 5, that is t raised to 3 minus 1. That is what we have. Therefore, we shall have our phi as, that is 1 into, this will be 4t raised to 1 minus 1 is 0. Then minus, this is 2 into 2t raised to 2 minus 1 is 1. Then minus 3 into, this is 5t raised to 2. That is 5t raised to 2. Therefore, we shall have, that is phi equals to t raised to 0 is 1. 1 times 4 is 4. 4 times 1 is 4. Then minus, this minus, t raised to 1 is, that is 1. That is t. T raised to 1 is t, times 2 is 2t, then times 2 is 4t. Then this is 3 times 5t squared. It will be 15t squared. Now, since this is the equation of velocity, then we can say that at t equals to 3, what will be our velocity? At t equals to 3, what will be our phi? So instead of t, we shall substitute with 3. Therefore, we shall have, that is phi equals to 4 minus 4 into 3, then minus 15 into 3 squared. And in that case, we shall have our phi as 4 minus 4 times 3 is 12, then minus, this is 3 squared is 9, times 15 is 135. Therefore, this will be 4 minus 12 is negative 8. Negative 8 minus 135 is negative 143. Now, we want to write, since velocity must have units, because displacement was in meters and time was in seconds. Therefore, this will be meters per second. Therefore, we shall have our answer as negative 143 meters per second, because our displacement, remember that we were differentiating, that is displacement with respect to time. That is displacement which is in meters with respect to time, which is in seconds. Therefore, our units of velocity will be meters per second. Therefore, the answer is negative 143 meters per second. That is the answer that we obtain there. Now, our second question says that find the time when the velocity is 0. Find the time when the velocity is 0. Now, our equation of velocity was phi equals to, that is 4 minus 4t minus 15, that is t squared. That was our equation of velocity that we have obtained. Now, the question is, find the time when the velocity is 0. If we substitute this phi with 0, therefore, we shall have, that is 0 equals to 4 minus 4t minus 15t squared, which is just the same as when we write our 0 on this side. This is the same as 4 minus 4t minus 15t squared equals to 0. Now, we want to obtain t here, that is time, because time is denoted by small t. So we want to obtain the value of, if we divide by a negative, that is on both sides, so that we make this positive, so that this one can serve our, that is, can serve as our first term, so that we have this equation, because it will now be easy to solve this, because it will be a quadratic equation. Since it is quadratic, There are four methods of solving quadratic equations. Now, the first one is factorization, the second one is completing the square method, the third one is a quadratic formula, then the last one is graphical method. Now, if we can use that is quadratic formula, then from the quadratic formula we can say t is given as negative t. So negative b, t is given by negative b. Our b here is 4, so it will be negative 4 plus or minus the square root of b squared. Our b is 4, therefore it will be 4 squared minus 4at. Our a is 15, so it will be 15. Then ac, that is our c is negative 4. Therefore we shall have that. Then over that is 2a. Instead of that is a, we shall have 15 because our a is 15. So we shall have 15. So our quadratic formula is usually, that is, we can say, let us write it here, negative b plus or minus the square root of, that is b squared minus 4ac, then all over, that is 2a. Remember, our b is 4, then our a is 15, and our c is negative 4. Because since that is what we have, then we can say that our t will be negative 4 plus or minus the square root of, this is 4 squared, which is 16. Then this is negative 4 times 15 is positive 60. Positive 60, not positive 60, but negative 4 times 15 is negative 60. Negative 60 times negative 4, it will be positive 240. It will be positive 240. Then all over 2 times 15 is 30. 2 times 15 is 30. Now, having arrived at that point, then we shall have, that is t equals to negative 4 plus or minus the square root of 16 plus 240 is 256. Then we shall have over, that is 30. Over, that is 30. That is what we have. Since we have, that is our t as negative 4 plus or minus the square root of 256 over 30, remember the square root of 256, that is from your calculator, is just 16. Therefore, we shall have our t as negative 4 plus or minus, that is 16. Then divided by 30. Now, since this is what we have, then we can therefore say that our t can be, that is our t can be, that is negative 4 plus 16. Negative 4 plus 16 is 12. Then divided by 30. Or negative 4 minus 16, it is negative 20. So it will be t is negative 20 over 30. But t cannot be negative. Since we have these two possibilities and we have said that t cannot be negative, therefore we ignore this one. And therefore we can say that our t will therefore be by 5, that is by 5 or by 6, 5. by 6 2, not 5. By 6, that is 2, and by 6, this will be 5. Therefore, this will be 2 over 5 seconds. That will be 2 over 5 seconds. That is the time when the velocity is 0. Because we have said that t cannot be negative. It cannot be negative. Therefore, time can only be positive. It cannot be negative. Therefore, we ignore this and take our time as 12 over 30. And when we simplify 12 over 30, we shall get, that is by 6, it will be 2. By 6, it will be 5. Therefore, our time is 2 over 5 seconds. Lastly, let us have a look at this question that find the acceleration at t equals to 2. Find the acceleration at t equals to 2. As we have said earlier, from the definition of acceleration, that acceleration is obtained by differentiating velocity with respect to time. That is, by differentiating velocity with respect to time. Since our velocity was, that is, our velocity was 4 minus 4t minus 15, that is t squared, we have to differentiate this velocity with respect to time. Therefore, we shall have, that is acceleration, is given by dv over dt, which is just the same as we differentiate this velocity with respect to time. Since this is a polynomial, if we differentiate 4, since 4 is a constant, it will be 0. Then let us differentiate 4t, that is negative 4t. The power of t here is 1. Therefore, we shall have this minus that is here. That is, the power of t is 1. So we shall have 1 times the term 4t raised to 1. But we reduce the power by 1. Then minus the power of t here is 2. Then we shall have 2 times 15 t raised to 2, but we less the power by 1. That is what we shall have. Then we shall say that our acceleration equals to negative 1 into, this is 4t raised to 1 minus 1 is 0. Then minus 2 into, this is 15 t raised to 1, which is just 15t. Now, this will be, that is, acceleration will now be negative 1 times 4t raised to 0 is just 4. Then minus 2 into 15t. And in this case, we shall have our acceleration as negative 1 times 4, which is negative 4. Then minus 30t. That is what we have as our acceleration. It is negative 4 minus 30t. Now, they say find the acceleration at t equals to 2. Now, we can say that at t equals to 2, what will be our acceleration? At t equals to 2, what will be our acceleration? So we have to substitute our value of t with 2. Therefore, it will be negative 4 minus 30 into 2. And in this case, we shall have our acceleration as this is negative 4. Negative 30 times 2 is negative 60. And this will be negative 4 minus 60, which is negative 64, that is meters per second squared. Remember that acceleration, the SI unit of acceleration is meters per square second.